Hi everyone, welcome back to Highway and Bridge Insights, the place where we break down the big ideas behind roads and bridges in a simple and engaging way. Today we're talking about something every driver, engineer, and road builder encounters: the difference between flexible and rigid pavements. You may have noticed that some roads are paved with black asphalt while others are made of solid concrete. But have you ever wondered why that is? Stick around as we explore the engineering behind these two pavement types, explain how they're built, and show real-world examples from Ethiopia, Africa, and beyond. What are flexible and rigid pavements? From above, roads may seem straightforward, but underneath, there's a whole world of engineering at work. Pavements are generally categorized into two main types: flexible pavements and rigid pavements. Here's how they differ and what makes each one unique. Flexible pavement. Flexible pavements are typically made of asphalt, bitumen, and various granular layers that flex slightly under traffic loads. Let's take a look at the structure. Surface course, the top asphalt layer providing smoothness and skid resistance. Binder course, a layer that helps distribute vehicle loads. Base course, crushed stone or gravel for structural support. Subbase, a layer of lower quality material for drainage and support. Subgrade, the compacted soil foundation. Key features of flexible pavements: adjusts and flexes under traffic loads. Faster and more cost-effective to construct. Requires regular maintenance every 10 to 15 years. Common types: conventional multi-layered asphalt pavements. Full-depth asphalt pavements. Advantages: smooth and comfortable driving experience. Lower initial construction cost. Repairs are faster and simpler. Adapts well to minor ground movements. Disadvantages: shorter lifespan, typically 10 to 20 years. Prone to deformation under heavy traffic. Affected by extreme temperatures, requires more frequent repairs. Rigid pavement. Rigid pavements are constructed using concrete slabs, sometimes reinforced with steel, and are designed to distribute loads over a wider area. Types of rigid pavement. Jointed plain concrete pavement, JPCP, uses regular joints to control cracking. Jointed reinforced concrete pavement, JRCP, includes steel bars to reduce crack spacing. Continuously reinforced concrete pavement, CRCP, no joints, continuously reinforced for durability. Advantages: lifespan of 30 years or more, minimal maintenance over time, resistant to oil and fuel spills. Ideal for heavy traffic areas like highways and airports. Disadvantages: higher initial construction cost, longer construction and curing period. Surface can be rough if not finished properly. Joints may need future maintenance. Structural composition, how they're built. The design and layering of pavement significantly affect performance. Flexible pavement, built-in layers with each level helping to distribute load to the subgrade. Rigid pavement relies heavily on a thick concrete slab, often supported by dowel bars and a solid subbase. The concrete spreads the load efficiently but lacks flexibility. Performance, how do they compare? Flexible pavement, quick and easy to construct. Less durable for long-term heavy traffic, especially in extreme climates. Rigid pavement, long-lasting and ideal for heavy vehicles, higher upfront cost and complex repairs. Enjoying the video? Give it a like to support the channel. Don't forget to subscribe and share with friends who love engineering and infrastructure. Global perspectives, how the world builds roads. Let's explore how different regions use these pavement types. United States, highways often use concrete, while asphalt is common in urban areas for quick repairs. Germany, Europe, prefers high-quality asphalt for highways. Concrete is used where longevity is critical. Africa, Ethiopia, asphalt is popular due to affordability, but concrete is gaining momentum for major expressways and airfields. Ethiopian context, what's being used? In Ethiopia, both flexible and rigid pavements are widely applied. Flexible pavements, asphalt roads dominate rural and regional areas thanks to their lower cost and faster construction. Rigid pavements, used in urban expressways and heavy traffic routes, such as parts of the Addis Ababa-Adama Expressway and various airfields, where long-term performance is key. Cost and environmental considerations. It's not just about engineering, sustainability and economics play a role too. Flexible pavements, made from petroleum-based asphalt, which is recyclable but has a higher environmental impact. Rigid pavements, concrete has a larger carbon footprint in production, but lasts longer, reducing the need for frequent reconstructions. So, which one is better? It depends. Go with flexible pavement when you need a road built quickly and on a tight budget. Choose rigid pavement when long life and high traffic capacity are your priorities. Both pavement types play vital roles in infrastructure. In developing regions like Ethiopia and other African nations, the balance between cost, durability, and sustainability is shaping how roads are designed.
The choice between flexible and rigid pavements significantly impacts the performance of road, regardless of whether it's a big highway or rural section. Flexible pavement, typically, which is composed of asphalt, offer advantage such as ease of construction, lowering initial cost, and adaptability to various weather conditions, making them the first choice in many regions. In Ethiopia and other African nations, there is a noticeable shift toward more durable and sustainable long-term solution as infrastructure development accelerated. This transition is driven by increasing need for roads that can withstand heavy traffic load, climate variation, and environmental factors. Despite this movement toward more resilient option, flexible pavement remain the dominant choice due to their good performance and cost effectiveness as well.
If you found this video insightful, like the video, subscribe to Highway and Bridge Insights, share with fellow engineers, students, and infrastructure enthusiasts. Thanks for watching, and I'll see you in the next video.